Hello and welcome back to more Chapter 6 Percentage and Diagrams. And the first paragraph is all about percentages. Now we can take a look at some diagrams. One short note, I will mostly just explain how the diagrams themselves work, how you can read them, how you can get information out of them, or how you can draw them. Remember, in the actual project and the exercises, you have to combine that quite often with exercises where you have to do percentage-based calculations. So remember to also know how to do that. That was, of course, the first paragraph. That means that for some diagrams, I will go quite quickly through the theories. Because, for example, the first one, here to the left, called a pictogram, or in Dutch called een beelddiagram. Yeah, yeah, yeah. What to say? It is what it is, right? This is a so-called diagram which we can use to now view data that we have collected. And sometimes this part of mathematics is also called descriptive statistics, beschrijvende statistiek, data weergeven op een visuele manier. And this is a very almost childlike way to use it. You will come, sometimes you do see those in papers and such, but we just use pictograms and little pictures to see what they notate. For one apple is 10 apples, a half apple is 5 apples. So apparently here I sold 10 apples in January and 40 in February and 25 in March, etc. But as the book already says itself, making such a graph yourself takes a lot of time. And you have to make a different legend here as well. You should label them correctly. I'm not a big fan of pictograms, and most mathematicians don't use them that often either. You will see them sometimes in papers and such. Where I would like to take a look at first is actual bar charts, and these are, I think, already a bit, well, not even a bit, they are a lot more efficient, and you will see coming them back a lot in papers, financial papers, economics, and also other parts, other subjects where you have to describe or visualize data. In a bar chart, in Dutch een staafdiagram, you use bars to notate how much certain things either happen or are available. For example, here we'll take a look at the availability of the number of bicycles in 2016. And here we have THCEO, and then here they say what T, H, C, A, and O stand for. For example, tour and city bikes, hybrid bicycles, children bicycles, electrical bicycles, and other bicycles. And now you can use the vertical axis here to then say, well, okay, apparently we had 40 times 10,000, so 40,000 tour and city bicycles, I guess, being sold. That's not really clear in this one. Normally you would write it down as well. I mean, number of bicycles what? Sold, available in the Netherlands, in the province. So you could say that's not very clear here, but what is clear is how much they are available. And you have to be careful, because here you can state, well, is this really clear? Is this 6? I guess this is 6. Is this 11 or 10 and a half? So sometimes you have to be careful with your axis as well. In general, in a bar chart, the length of the bar shows the amounts. The bars are labeled to show what they represent, right? So here are the labels. The bars are separate. That is quite important, actually, because in the near future we'll see something that looks a lot like this, but then the bars are connected, and that's actually a different kind of diagram or chart. Okay? And now you can get information out of this diagram or this chart and calculate with that. That's what you're going to do in most of the exercises in the project as well. Another commonly used chart is a so-called line chart, a lijndiagram. And a line chart you oftentimes use when you want to represent something happening over time. For example, here the time being from 2007 up till 2016. You can very easily now show how much, in this case, electrical bicycles are sold in each year. and you can see a trend happening or not, right? The trend was that there were an increase in sales, then a small dip, and then an increase again and a small dip. You can draw a line chart as follows, but the year is on the horizontal axis always, right? If you have something on time, put it on the horizontal axis. In this case, the number of bicycles sold on the vertical axis. Mark the number of electrical bicycles sold each year by a dot, right? So the dot are the data points, you can say, and then connect the dots with straight lines. In a case of this, you connect the dots with a straight line. So here you can use your protractor, right? This is not a parabola or something where you may not use your protractor. Here you have to use your protractor. Okay. As you can see, there's this weird little symbol here. This is called a tear line, or in Dutch, een scheurlijn. If we start at 80, well, and there was no 60 or 40 and 20, to prevent this diagram from coming too tall, or this graph, you say, well, the first few numbers on the vertical axis I'm going to skip, put in a tear line here. Okay? Because otherwise this diagram would be this large. And let's say we wouldn't start at 80, but we would start at 180. Yeah, then we have quite a big part of the chart that we would like to skip. You can do that using a tear line. And again, you can now read off certain data points and then calculate with them. For example, I'm not going to write down calculation here, but what is the percentage increase in the amount of electrical bicycles sold in the Netherlands if you're going to compare 2011 with 2014. So 220,000 and 180,000. You can do increase divided by odd, and so you can calculate the percentage increase between two data points on a line chart. Theory B is all about pie charts, or in Dutch called een cirkeldiagram. Heel soms noemen mensen dit een taartdiagram in het Nederlands. Daar word ik persoonlijk niet heel blij van. Zie je wel terugkomen, maar meestal noemen we dit gewoon een cirkeldiagram. A pie chart is always going to be divided in an amount of sectors. In this case, for example, here we have 5 sectors, in Dutch sectoren. 1, 2, 3, 4, 5. Again, it's important to label them so we know what each sector represents. And oftentimes you see that the percentage itself is written inside of the sectors, so we can know what percentage they represent. All sectors together in a pie chart always make up 100%. That's important, right? So here you can calculate this part by doing 100 minus this, minus that, minus this, minus that. You can also calculate how big this angle is of a certain sector. And that's important if you want to draw a pie chart yourself. Because remember, a full angle is 360 degrees. And here, 12% of that 360 degrees is going to be less than 300. So what I can do is 0.12 times 360 degrees to calculate the actual angle here. They call it the central angle. That also came back in chapter 2, I think, central angles, right? And we can also again calculate stuff like here. For example, there are 30 students in class 2F, of which 19 bike to the school, 7 take the bus, and 4 walk. If I now want to calculate how big the central angle is of bus, and I take the amount that take the bus, 7, divided by the total amount, 30, and I do times 360 degrees. Then I have my central angle that is going to be connected to my sector bus. So how can you now, for example, draw a pie chart yourself? First, calculate the central angles of the sectors. I'm going to show you again how to do that in a moment. Draw a circle and a vertical radius. This one, the first one that you start with. And then you're just going to measure the central angles clockwise and color the sectors. Write a title and a legend for the pie chart, both important. Title up above so you know what this is about, and a legend that is going to say what each color, each sector represents. For example, how to draw a pie chart. If I have a table right here, and I want to represent this data in a pie chart, first of all those things together are going to be 100%, right? But I don't know what all those things together are. So the first thing that you're going to do here is add them all together to find what amount is 100%. So here, first add all those things up. We'll find that the total amount is 17.9. Okay? Then what you're going to do is you're going to now try and calculate all the central angles of those sectors. You do that by, for example, for hotel guest house, say 7.7 divided by total, so this part divided by total, times 360 degrees. Not times 100%, then you're calculating the percentage, right? Sometimes that's also a question, hoeveel procent van het aantal is nou hotel guest house? Ja, dan doe je 7.7 gedeeld door 17.9 keer 100%. Dan heb je het percentage. Ik zoek hier niet naar percentage, ik wil dit ding gaan tekenen. Voor tekenen heb ik hoeken nodig. Niet keer 100%, keer 360 graden. So here that will give you approximately 155. For campsite, 2.9 divided by total times 360. For bungalow, 2.7 divided by 70.9 is 360 times 360, etc. And now you find all those angles, and all those angles added up are 360 degrees, or at least almost, because you do round somewhere, right? Angles we oftentimes draw rounded to whole numbers, because yeah, otherwise it's very difficult to draw them. Now we have all the central angles. Now draw a circle, draw a vertical radius, that's step 2. And here it's difficult for me to show you how they did that, but they draw them all like this. This is your vertical radius, what you start with. Then they measured 155 degrees, that is this one. Then from here on out, they put their protractor here, so they then going to calculate 58 degrees. Then they're going to draw 54 degrees, that's right here. Then 34 degrees and 58 degrees. And if you're going to do that correctly, you will find this. Color them or label them. Now you have to color them and then label them. Sometimes they also, instead of colors, used a certain pattern. You can use that as well. Draw legends and draw a title, and make sure that this title is going to be quite clear. Here, accommodations of the foreign holidays 2016 with a total of 17.9 million. Right, and you could also write down the percentages right here, but you don't have to do that. If you're going to do that, you also have to calculate the percentages right now, and that takes extra time, and you don't need to do that. Okay. Again, if you want to do that, then you do 7.7 divided by 17.9 times 100%. Okay, and that are going to be the pie charts. In your book, they also have ternary diagrams. We're going to skip those. They also don't come back on the project, so don't worry about them, okay? You don't have to do ternary diagrams. And here are all the glossary words. Be sure to understand them. And again, I wish you good luck with your projects.